Hey guys, so today we're going to cover 7.7. This is the last section of the chapter, so that's really exciting. Be prepared for a test soon. Okay, so objectives today, we're going to factor special trinomials. So this is 7.7, factoring special cases. Now, if you remember the first half of chapter 7, we learned how to FOIL special cases, okay, like a plus b quantity squared, or conjugates, a minus b times a plus b. Well, that's what we're going to need to get as our answers today, okay? Special cases like that. So let's start with the factored form of x squared plus 14x plus 49. Okay, there's our first example. So some definition here. A perfect square trinomial results when a binomial is squared. The first term and the last term are perfect squares. The middle term is twice the product of the first and last terms of the binomial. So what this is saying, can I take the square root of the first term? So do I know the square root of x squared? Absolutely. It's just x. Okay, and then I look at the last term. Can I do the square root of 49? Absolutely. It's just 7. Then it says multiply these two together, so I get 7x times 2. Does that match what's here in the middle? Absolutely. So we know that this is a perfect square trinomial. Okay, that's how you recognize it. Square root of the first, square root of the last, multiply them together and double it. That's what you get in the middle. Okay, that's a perfect square trinomial. So how do I factor that? Okay, sorry, I wanted to keep going here. Well, it's pretty easy. Let me write it again down here. We just do our two sets of parentheses like we're used to. How do I make x squared? X times x. Okay, then I need to do my factors of 49 that I can make 14 out of. So if I list my factors of 49, 1 times 49, and 7 times 7. Can I get 14 out of either of those? Can't out of 7 and 7, so 7's go. Check your signs. This is positive, so that means the signs are the same. Look here, they're both that sign, so plus 7, plus 7. So my answer is x plus 7 times x plus 7. Or if you want, you can write it like this. Remember, when I have something times itself, it just means it's squared. So it's really the same thing as x plus 7 squared. Okay, so this is really no different than what we have been doing. Okay, so let's do another one. Let's factor 9x squared minus 30x plus 25. Okay, sometimes with these, it's really nice to check, is it a perfect square trinomial? So let's check. Can I take the square root of 9x squared? Absolutely, it's just 3x. Can I take the square root of 25? Absolutely, it's just 5. Multiply these two together, you get 15x times 2 equals 30x. Look, that's what's in the middle. Okay, so we can go ahead and reverse FOIL. Do my two sets of parentheses, shortcut. You can take this square root. Because it's a perfect square trinomial, this is the only time I can do it. I know 9x squared is the same thing as 3x times 3x. And I know this 25 is going to be the 5 and the 5. Check real quick. 3 times 5 is 15. 3 times 5 is 15. 15 and 15 make 30. So we know we're okay. Let's check our signs. C is positive, so signs are the same. Look here. It's minus, so they're going to be both minus. Or you can write it as 3x minus 5 squared. Okay, so there is your answer. Okay, pause the video and try these two problems, please. Okay, again, I like to check to see, are they a perfect square trinomial? Well, square root of 4x squared is 2x. Square root of 9 is 3. Multiply them together, 2 times 3, 2x times 3, sorry, is 6x times 2. That gives me the 12x. Okay, so I can do my two sets of parentheses, 2x and 2x, and then use that 3. Check your sign. C is positive, B is positive, so they're both plus. Or you can write it as 2x plus 3 squared. Okay, one more. Again, I like to check to see if it is. Okay, square root of x is x, or square root of x squared is x, square root of 16 is 4. If I multiply them together, I get 4x times 2, gives me that 8x. So this looks like a perfect square trinomial. Two sets of parentheses, you can do the shortcuts, the x and the 4. Okay, let's check our signs. C is positive, signs are the same. They're both negative. Okay, so x minus 4 times x minus 4, or x minus 4 squared. Okay, so the other type of perfect, or other type of special case we have is called difference of two squares. Okay, so the key word here is 2. You want to do the difference of two squares if you have a minus sign and you have two terms. So let's check out x squared minus 9. Okay, so notice you can do the square root of x squared, which is just x. Square root of 9 is 3. Okay, so that's another way you can check. It's a minus sign, and I can take the square root of both of those terms. So let's look at it. Let's reverse FOIL. Okay, two sets of parentheses. How do I make x squared? X and x. Now the thing here is we don't have a regular x term. So really, we could say this is x squared plus 0x minus 9. So my factors of 9 are 1 and 9, and 3 and 3. Can I make 0 out of either of those? Absolutely, out of that 3 and the 3. Okay, so shortcut, look at the 3's here. Okay, now if I check out the signs, C is negative, so signs are different. Okay, so I know one's minus, one's plus. Okay, remember we called these conjugates when they were exactly the same except for the sign in the middle. So when I reverse FOIL the difference of two squares, they reverse FOIL into conjugates. Let's try another one. Can I take the square root of 4x squared? Absolutely, it's just 2x. Can I take the square root of 81? Absolutely, it's just 9. So, square root of both of them. Oh, we had a minus sign in the middle. That tells me it's the difference of two squares. So I'm going to take the 2x and the 2x, take the 9. Okay, remember these are conjugates, so one's plus, one's minus. That's it. Okay, here's two problems. Please pause and try these. Okay, again, I like to check, can I do the square roots? Square root of x squared is x, square root of 64 is 8. So, two sets of parentheses. Okay, again, because of the minus. X and x, put an 8 and an 8. They're conjugates, so plus and minus. Okay, check this one. Square root of 9x squared is 3x. Square root of 100, 10. I got a minus sign, so yes, this is the difference of two squares. Two sets of parentheses, start with the 3x, put the 10 in both of them, and it's difference, so plus, minus. Okay, always remember though, you gotta check for GCF. Okay, that's our first rule of factoring. So let's check out our first rule of factoring. So, why that move? So I have 3x cubed y minus 12x y squared. Let's start with the numbers. Can we think of anything that goes into both 3 and 12? Oh, 3 does. Okay, check out your letters. Do they have any x's in common? I have 3 and I have 1, so they have one x in common. Check out my y's, 1 and 2, so they definitely have at least 1 in common. So let's see what we have left. Okay, if I have 3 times what gives me 3, it's just a 1. I had 3 x's, I took 1 away, so I still have an x squared. I had 1 y and I took it away. Okay, so 3 times what gives me negative 12? 3 times negative 4. I had 1 x and I took it away, so I don't need to worry about the x's. I have 2 y's and I took 1 away, so I need 1 more y. Okay. Actually, they made a mistake here. Give me a second, let me think about it. This is a mistake because you can't go any further. In the textbook, I believe they made this y squared here. Okay, we can't go any further here, but okay, if I made it 3x cubed y squared, my GCF would become y squared, and then I wouldn't have this y here. Now it's the difference of squares, so I can keep going. Okay, so fixing a typo there in the textbook. I leave the GCF alone because I can't do anything with that guy. He's already taken care of. So I got two terms. Let's see if we can take the square root. Square root of x squared is just x. Square root of 4 is 2. So this looks like it's going to be conjugates to me. Put the x and the 2 in both parentheses. And it's a minus, so we know one's plus, one's minus. So there's your answer there. Okay. Okay, your turn to try. Please pause the video and try these two problems. Okay, letter A, remember first rule of factoring is always look for GCF. So can I have something that goes up to 4, 24, and 36? 4 goes in all of them. Check our x's. I have 3, I have 2, and I have 1. Oh, 1's in common, so let's pull 1 out. Okay, so 4 times what gives you 4? It's just a 1. Okay, I had 3 x's, I took 1 away, so I have 2 x's left. 4 times what gives you 24? 4 times 6. I had 2 x's, I took 1 away, so I still have 1 more hanging around. 4 times what gives you 36? 4 times 9. I had 1 x, took 1 away, so I don't have to worry about any more x's. Okay, so again, remember, you leave the GCF alone. I'm seeing 3 terms, so let's see if we have a perfect square trinomial. Square root of x squared is just x. Square root of 9 is 3. If I multiply those together, I get 3x times, and then always remember times 2. Do I get what's in the middle? Yes. So this is a perfect square trinomial. So I can put my 2 sets of parentheses, x times x. Okay, remember, you also could do it this way. 2 numbers are multiplied to 9, and I can add them to make 6. That's just 3 and 3. Check out your signs. C is positive, so we look to B. A means both signs are plus. So your answer is 4x times x plus 3 times x plus 3. Or you could write it as 4x times x plus 3 squared. Okay, so check out the next one. First rule of factoring, again, remember, is GCF. 50x squared minus 32y squared. Oh, they're both even, so I know 2 goes into both of those. They don't have any letters in common, so let's just pull out the 2. 2 times what gives you 50? 2 times 25. And the x squared still hangs out. 2 times what gives you 32? 2 times 16. Okay, and leave the y squared. Okay, oh, this looks like I have 2 terms. Let's see if I can take the square roots. 25x squared, the square root there is 5x. 16y squared, square root there is 4y. Oh, we do have the difference of squares. So leave the 2. Okay, put the 5x in both of them. Put the 4y in both of them. And it's the difference of squares, so that's conjugates. One's plus, one's minus. And there's your answer. Okay, real quick, I want to give you some square roots that you should know. Okay, square root of 1 is 1. Square root of 4 is 2. 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 18 would be 324, I believe. 361 for 19, and 400 for 20. Okay, you should know these. That'll make your life easier with some of these. Okay, so I would pause and make sure you write all these down. All right, so here's our concept summary. So remember, there are 2 patterns here, but you can absolutely think of it as what 2 numbers multiply to the last, and I can combine them to make the middle term. Okay. And here's your homework. Page 305, you're going to do problems 18 through 20, and then 31 through 45 odd. As always, if you have any questions, let me know. Hope you guys have a great day.